The Andes Tunnel is set to become one of South America's most ambitious engineering feats, cutting through the towering Andes Mountains and connecting remote regions of Chile that were once isolated by harsh terrain. This $15 billion highway tunnel isn't just a road, it's a lifeline, designed to drastically reduce travel time across some of the most treacherous mountains on Earth. Spanning kilometers underground, the tunnel represents a massive financial and technological commitment, making it one of the largest infrastructure projects in Chile and the entire continent. Its scale and complexity raise critical questions. How did engineers plan to carve through the world's tallest mountains? What makes this mega project so risky? And could it transform Chile's economy and transport systems forever? The tunnel is located in the Andes Mountains of Chile, a region notorious for its extreme altitude, seismic activity, and rapidly changing weather conditions. For decades, travel between Chilean cities in this area relied on dangerous mountain passes, prone to landslides, snow blockages, and long detours. The Andes Tunnel aims to shorten travel times, improve safety, boost trade routes, and promote tourism by providing a reliable all-weather connection across the mountains. This is a multi-billion-dollar investment with advanced engineering designed to withstand earthquakes, shifting rock formations, and heavy snow loads. The project has been in planning for several years and involves international collaboration with leading engineering firms, state-of-the-art tunneling technology, and multiple construction phases to ensure both safety and efficiency in one of the planet's most challenging terrains. Constructing the Andes Tunnel requires some of the most advanced engineering techniques in the world. Due to the extreme altitude and varying rock formations, engineers are employing a combination of drill and blast methods alongside tunnel boring machines, TBMs. These hybrid methods allow teams to adapt to both soft sedimentary rock and hard granite, ensuring stability throughout the excavation process. To reinforce the tunnel, steel arches and shotcrete linings are installed continuously, while sophisticated drainage systems manage water seepage from snowmelt and underground springs, a major challenge in the Andes. One of the greatest obstacles is the geological instability of the Andes, which includes frequent seismic activity, landslides, and unpredictable rock shifts. Engineers have integrated real-time monitoring sensors, laser scanning, and geotechnical instruments to detect stress in the rock and alert crews to potential collapses. Safety measures also include emergency escape tunnels, ventilation systems, and high-tech communication networks to protect workers during construction. Harsh weather conditions, extreme cold, high winds, and heavy snowfall further complicate the work, requiring temporary shelters, heated equipment, and specialized construction schedules. Despite these challenges, the project demonstrates cutting-edge engineering and international collaboration, combining expertise from Chilean and global tunneling firms. This tunnel not only aims to set records for scale and complexity, but also serves as a model for future infrastructure projects in similarly extreme mountain environments. The Andes Tunnel is more than an engineering marvel. It is poised to transform Chile's economy and regional connectivity. By cutting through the mountains, the tunnel will significantly reduce travel times between key cities, allowing goods, services, and people to move more efficiently. This is especially important for mining operations, one of Chile's largest industries, as it will streamline the transportation of minerals from remote high-altitude sites to ports and processing centers. The tunnel also has a major impact on tourism, opening up access to scenic Andean valleys, ski resorts, and historical towns that were previously difficult to reach. Easier access can boost local economies, create jobs, and stimulate small businesses along the route. Additionally, the project strengthens national infrastructure resilience by providing a safer alternative to winding mountain passes which are prone to avalanches, landslides, and snow blockages during winter months. On a strategic level, the Andes Tunnel positions Chile as a regional transport hub, facilitating trade with neighboring countries and improving logistics across South America. By combining economic efficiency with advanced engineering, the tunnel is expected to deliver long-term returns far beyond a $15 billion investment, reshaping both local and national development while connecting communities once separated by one of the world's most formidable natural barriers. Building a tunnel through the Andes comes with enormous technical, environmental, and financial risks. Geologically, the mountains are young and unstable, with frequent earthquakes, landslides, and rockfalls. Even with advanced monitoring and engineering, the natural volatility of the terrain poses a constant threat to both construction crews and the tunnel's long-term integrity. Weather conditions add another layer of complexity. The high-altitude environment brings extreme cold, heavy snowfall, and sudden storms, which can halt construction, damage machinery, and delay schedules. Water seepage from snowmelt and underground aquifers also poses risks of flooding or erosion, requiring extensive drainage and waterproofing systems to prevent structural failures. Financially, the $15 billion price tag makes this one of South America's costliest infrastructure projects. Any delays, unforeseen geological issues, or engineering setbacks could inflate costs even further, putting pressure on both government budgets and private contractors. Environmental concerns are also significant, as tunneling through sensitive mountain ecosystems can disrupt wildlife, water sources, and fragile habitats, raising questions about sustainability and regulatory compliance. Despite these challenges, project leaders remain confident that careful planning, cutting-edge technology, and continuous monitoring will allow the Andes Tunnel to overcome nature's obstacles and deliver transformative benefits for Chile. The Andes Tunnel has not been without controversy. Many environmental groups have raised alarms about the impact of tunneling through fragile mountain ecosystems, warning that the construction could disturb glaciers, rivers, and habitats of endemic species. These concerns have sparked debates about whether proper environmental assessments were conducted and whether mitigation measures are sufficient to protect the region. Critics have also questioned the financial management of the project. With a $15 billion investment, skeptics worry about potential cost overruns, corruption, and contractor mismanagement. Some have argued that the funds could have been allocated to improving existing roads or investing in alternative transport solutions that carry lower environmental and financial risks. Additionally, indigenous and local communities have voiced concerns about displacement, disruption of traditional lifestyles, and lack of adequate consultation. While the tunnel promises economic development and connectivity, balancing progress with social and environmental responsibility remains a contentious issue. Despite these criticisms, proponents insist that the project's long-term benefits for trade, safety, and regional development outweigh the challenges, positioning the Andes Tunnel as a transformative yet debated megaproject. The Andes Tunnel offers crucial lessons for megaprojects in extreme environments. One of the most important takeaways is the necessity of advanced geological surveys and real-time monitoring. Even with state-of-the-art technology, tunneling through unstable mountain formations requires constant vigilance, adaptive engineering strategies, and robust risk management protocols. Future high-altitude or mountainous projects will likely incorporate enhanced structural reinforcements, AI-assisted monitoring systems, and emergency response planning to reduce the risk of collapses or delays. Environmental sustainability has also become a priority, with plans to mitigate glacier, river, and wildlife impacts and involve local communities in decision-making processes. The Andes Tunnel sets a benchmark for engineering in extreme conditions, demonstrating that cutting-edge technology and international collaboration can overcome seemingly insurmountable natural challenges. At the same time, it underscores the importance of balancing ambition with safety, environmental stewardship, and social responsibility, ensuring that future projects are both successful and sustainable. The Andes Tunnel is shaping up to be one of South America's most ambitious and transformative infrastructure projects, promising to connect remote regions, boost trade, and revolutionize transport across Chile. Yet its massive scale, technical complexity, and environmental challenges make it a project watched closely by engineers, governments, and environmentalists alike. As construction progresses, the tunnel will not only reshape the Andes landscape and Chile's economy, but also serve as a global example of high-altitude, large-scale tunneling. It demonstrates both the potential of human ingenuity and the challenges of working in extreme natural environments. What do you think? Will the Andes Tunnel live up to its promise as a modern engineering marvel, or will the risks outweigh the benefits? Comment below, and don't forget to like, subscribe, and hit the notification bell for more videos exploring the world's most ambitious mega projects and engineering breakthroughs.